Good afternoon, everybody. Thank you for the honors to speak at today's webinar to tell about a project that we have implemented in Russia at one of the factories of the global company. We will tell you about the most significant project for us because the aspiration of the customers team, the Beko company, are very close to the concept promoted by Janitza and we, their modest partner, ZEVSELECTRO. Okay. First, I'll tell briefly about myself. My name is Vitaly Ponomarev. I am founder of Zeuselectro, a power quality laboratory. Well, I'm engineer working for 15 years in electrical power industry. Also, for last 10 years, I'm working in the industry of measuring power quality parameters. Especially with Janitza as a partner. At the left picture, you see the group photo with Markus Janitza taken at one of the first trainings in Germany, led by Rudolf Müller in 2009. And the second photo, we are together with Gerald Fritzen in 2015 at DC Forum in Moscow. Our laboratory performing several services as a long-time partners of Janitza. We fully share the ideology of regard of electricity management, and we use this in our daily work. Like Janitza, we perform the following services for clients: on-site power quality management, how to prepare a power quality report, time measurements, and measurements related to faults at customer sites. Test drive of the power quality analyzer at the customer's facility without power outage. This is the best way to get to know Janitza technology and feel it yourself. Most often customers start purchasing analyzers after this service, after testing the devices. The implementation of GridVis software is the most important step, after which the customer receives not only a measuring device, but an energy control system. We're able to use 100% Janitza technology only using GridVis. Of course, the electricity monitoring systems allows our customer to make informed decision to solve problems in the power grid and implement the new technological and energy equipment. For example, power factor corrector, static reactive power generator, active harmonic filter, and active voltage regulator. Okay, let's come to our reference project. Beko is owned by Arçelik company, is a Turkish multinational household appliance manufacturer. It's a global company. Company operates 15 production plants in several countries, including Russia. The company Beko owned by Arçelik. One of the Beko factories is located in the central region of Russia. The place is called Kirjach. It's about 120 kilometers to the northeast from Moscow, near the Vladimir city. Factory founded in 2006. It's able to produce about 3,000 washing machines and about 2,000 refrigerators every day. The factory works to the Russian market and to the CIS market. The factory has high productivity and operates in the market of low-cost household appliance. Therefore, the main task is efficient production and efficient use of resources, including electricity, steam, water, natural gas, heat, and so on. We can say the project began in 2014 with the trial installation of the UMG 604. First one, and then several dozen of devices were installed. In 2018, many factors were taken into account when developing the energy efficiency plan, and it was decided to continue with Janitza technology as the most important part of the suitable energy management model. Project targets is to develop a sustainable energy monitoring business model with central energy monitoring project. It's a central monitoring system which control the production line at all. The main goals of the project is to establish a sustainable energy management business model, to monitor energy KPIs in real time and visually by collecting the energy data and receive from enterprises at the maximum 15 minutes in the central database, to implement a software that provided real-time monitoring in our facilities that do not have an energy monitoring system or are insufficient, to make minimum investments and shorter time and best efficiency. Project stakeholders are Central Production Engineering Management, is a central office of the Arcelor company, and the local IT management. Determination of energy parameters in new investment visibility process in the Central Production Engineering side of the project, and in IT management, it will serve in the parties of ensuring standardization in energy monitoring software and hardware to processing and energy data collection. Separate targets can be given to each department, which with the monitoring to be made in the cost centers diffraction. In this way, energy management will be transformed into the business culture and applied all together, not through a few responsible people with the business. At the fourth phase, it will have a machine-based measurement and monitoring capability. In this way, the efficiency of the equipment, idle time, fixed energy consumption can be calculated, and target consumption can be determined. And at the first phase, it will be able to evaluate, analyze the big data, obtain machine-based and real-time over the energy monitoring software. That was the technical description, and what we got in implementing GridWiz Ultimate and Janitza technology. Energy monitoring structure today of Beko factory consists of all the energy resources, including, of course, electricity and others, vacuum control, natural gas, water, steam, and temperature control. A single resource accumulates data on energy resources with setting, access, write, and output information. The control of power supply system is carried out in accordance with power supply scheme and in accordance with the cost centers. Control of quality parameters is electrical energy. Documentary evidence of changes in the quality parameters of electrical energy is the main point of the electroenergetical departments. The main important feature is virtual device. Virtual device make it possible to implement the structure of energy resources according by the cost centers, workshop, installations, and every single product produced by factory. Instant analysis by the manager of changes in the structure of energy consumption thanks to the output of the Sankey diagram on large screens in production. Visualization by shift and equipment stimulates employees to unspoken competitions to reduce energy consumption per unit and quality released product. GridWiz Web reducing energy consumption by automating the adjustment of production cycles, reducing the number of defective parts released due to the complex analysis of structured data of the combined system and control of changes in the parameters of energy resources and the environments. Improved productivity due to the improved microclimate control of operation correction and temperature correction, reduction of heat losses of structure due to the online assessments of temperature differences in different zones at the zoom and the prompt restoration of the temperature loop. Individual setting of compressed air pressure, vacuum, in the context of obtaining the best ratio energy consumption and finished product quality. Let's see to the project details. Totally implemented about 285 devices, including third-party devices, power meters, gas and water meters, and also virtual devices. This is the short part of the list of the devices of the real screen of GridVis software. Here's some slides from the GridVis program that our work screens for specialists communicate with every day. This is the daily report made in the GridVis Automate system used by technologists and production managers every day. This is the screen which is difficult to get from, for example, Excel, only in the GridVis Automate system. The first screen, the second screen. The second screen is not enough. This is the version of the whole report, including the heat maps, graphs, and tables of the whole process. Here are some Sankey diagrams with the real data. It's a very mesmerizing sight. It allows you to see that the factory is breathing as if it were alive. Very interesting view. If you see online data, picture changes every second. The next view of Sankey diagram. One more. This is the simple table and the simple bar graph of the Sankey diagram of the energy consumption for the printed reports. This is the screen of the temperature monitoring system, also implemented in the GridVis Automate. As you can see, this is the numbers of temperature in degrees centigrade, which are controlled in real time with the temperature sensors implemented directly to the GridVis software. This is the historical data of the temperature monitoring, including the graph, including the heat map, and the online data. This is the simple bar graph and table of the energy consumption. This is the utilization report, a very important report because it shows the real load of the power transformer of the electricity grid. And the main report, this is most important report of electricity consumption at the factory. Only virtual meters are used here. Data from 10 or more metering points are involved in each line. Sorry, the closed numbers, we had to hide them because I hope this is not important now. The result is an expense by loss centers, which is then sent to the production monitoring system, and accurate control calculation of the resources expended to each production line and for each product unit is made. Uptime report is an important report which allows to chief power engineer to find a common language with technologists and electricity suppliers, which shows how many events comes from electricity grid and how many seconds or percent of time network grid was unavailable. This is a short description of the project, which is implemented now. The project is in progress on Beko factory at the moment. So the total devices implemented in the factory is several hundreds of devices. The project is under construction now, and I think this with the more effective and covers all the factories plants system. So the main insights of this project was that the GridVis software is very effective and very short time to implement system. which you can use out of the box. And using the UMG devices, you can easily manage your power consumption and power quality and improve your system with also Janitza devices and third-party devices. If you have any questions or any comments, I would be pleased to answer well.
Okay, thank you, Vitaly.
Okay.
I would say we're waiting 2 minutes and maybe there come some
Okay.
questions.
Okay. 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 During waiting the question, I want to comment that at this project we use several devices of UMG 103 CDM, UMG 604, a lot of UMG 604 devices, and some Pro Data devices, and a lot of third-party devices as power meters, flow meters, temperature meters, and so on. This project is very interesting for me. As far as I can see, we have how many times do you spend to reach the results in Beko project? How many times, if you mean, do you spend to reach these results? This project is implemented more than half of the year. So we have no special team from the customer side to implement this project. So this project made by our side time to time and by a customer side time to time. There's no special team. So we implement it not so fast, slowly, but step by step. Okay, can you briefly tell about temporary meter that you showed at the start of the session? Temporary matter, I don't know. Let me guess what we're thinking about, what we're speaking about at the start of this question. Okay, I find out the first. I guess you tell about the virtual device. Sorry. Oh, I forgot where is my virtual slide.
Mr. Sachin, do you mean the virtual device?
Yeah. If you mean virtual device, at this project we used a lot of virtual devices as a calculator. Yeah.
Mr. Sachin, right now the one which you put in the box.
Oh, the first one. Okay. On the first slide. Do you mean this? Yeah.
Is this the right one, Mr. Sachin?
Oh yeah,
Yes.
This is our development. This is our version of MRG device. We put the UMG 605 in the small case with the Rogovsky coil adapters to make temporary analysis. So this is the small version of MRG which you can usually take to the plane in the cabin. This is the schematic version of the MRG Janitza device. The only things is the smaller than original. So this is our own development. I can send. Okay. I can tell more and more about this project and answer the most of the question. So, but time is okay. We have new question. Do you use transducers as input of gas air and water to feed into the input of UMG or uses the third party? Well, as you know, UMG 604 has Modbus via RS485 interface or analog temperature input. Not all the transducers use such interface, so we have to use analog transducers which reduce analog signal 0 to 10 volts and 4 to 20 milliamps to transfer it or via Modbus TCP or via Modbus RTU interface. But all of the data collected with the GridVis Ultimate. So my answer is third-party devices we use sometimes. Okay.
Thank you, Vitaly.
Okay. You can remember my email. Okay. Okay.
We have one question more.
Okay. Hi, Vitaly. Great project. Can you please let me know what were some of the competitors in the initial stage and what was the main points to choose Janitza? Okay, to choose Janitza. Okay, the main point to choose Janitza is the, as I said at the beginning, the test drive of UMG 604 several years ago. After this test drive, the specialist from Beko ordered several tens of devices before the whole project. They test for several years these devices. They knew about GridVis desktop system. So after this, they invite me to make a presentation of GridVis Ultimate. So this was the main point, that they have historically experience of using UMG 604. Okay. Okay.
Okay, great, Vitaly.
Oh, great.
Seems that we do not have further questions.
Okay. Thank you, everybody, for questions. Thank you for attention. I hope it was interesting. Sorry for my not so good English. I'm ready to contact. You can ask for my email at the beginning of the presentation. So thank you for everybody.
Yes, thank you, Vitaly. It was very interesting, and we hope you enjoyed this webinar. And if you will have questions, please feel free to contact us or Vitaly. And yeah, now we will close the session. Thank you very much.
Okay, thank you. Thank you. Bye-bye.